For our last speaker of the day, our last speaker indeed of DevOps Days Ukraine 2023, is an individual who, I mean, almost needs no introduction, but I'm going to give one anyway. Is Charity Majors, an engineer, a manager, a C-level at Honeycomb, specializing in observability for distributed systems. Previously managed production engineering at Facebook, worked at Parse, contributed to Linden Lab. If you remember Linden Lab, everybody, a co-author of Database Reliability Engineering, one of the seminal works on the topic, and also an individual who transitioned from classical piano performance to building systems and teams. Ask questions. Ask questions in the Slido app. You're going to have questions. Please ask them. We're going to go through them at the end. And you're going to want to ask those questions because, as I mentioned at the outset of today's festivities, this is the only way that you're going to get entered into the raffle for the KubeCon tickets. Thank you, CNCF, and everybody for making those tickets available. So if you're interested in getting free tickets to KubeCon, ask questions in the Slido, and we're going to choose a winner from that list. The topic is compliance and regulatory standards are not incompatible with modern development best practices. Charity is basically going to tell us why a bunch of stuff is nonsense bullshit. So Charity, welcome to the stage.
Yay, thank you so much for having me. I love that. Why a lot of stuff is nonsense and bullshit. That could really sum up my entire career. All right, I'll go ahead and share my my slides now and my screen, and we'll get going. By the way, this is only the second time that I've ever given this talk. The first time was just a couple of weeks ago, and it kind of snuck up on me. It's something that I have been trying to get other people to write for a very long time, and then I started threatening to write it myself. Even though I am not in any way, shape, or form, I don't consider myself a security expert at all. But I I am on Twitter, and I do get this constant stream of people going, "Oh, I love the stuff that you talk about, but if only we could do it, we can't because, alas, we are in a regulated industry, or we do fintech, or we do medical devices, or we do all these things, and therefore we can't do any of the stuff that you talk about." And I know this isn't true. I know this isn't true because Google is subject to the same regulatory frameworks. Amazon has figured this out. Even GovCloud has figured this out. And so I decided I was going to research and figure out what's at the root of all of these myths. And so here we are. I'm pretty stoked about this. That was a great introduction, so I won't rehash it. I will only add that we are at the very tail end of giving away free copies of Observability Engineering. So, slide 2, slide 3. Right, let's start this again. How well does your team perform? This might feel like a loaded question. It might feel like an unanswerable question. But let's start here. How well does your team perform is very much not the same thing as how good are you at engineering. When I think of higher performing teams, I think of teams that get to spend most of their time solving interesting problems that move the business materially forward. And the lower performing you are as a team, the more of your time you spend on literally everything else. And if you're wondering how to measure how high performing your team is, a good place to start is with the DORA metrics. Now, these are not the entire story, but they're, especially for modern SaaS companies less than 8 years old or so, they're a really good starting place. How often you deploy, how long does it take for your code to go live, how often does it fail, how long does it take to recover. I feel like every engineering team, every engineering manager should be tracking these. You should know where you stand. And I would add a fourth, which is how often are you alerted outside of work hours? There's a pretty big gap between, like the top N% and the rest of us. Like it's the difference between like under an hour and under a day. And it really pays off, obviously, to be in a high performing team. Like, think of the sheer amount of human misery contained in this gulf when you get to deploy like 6,000 times more often. The competitive advantage for teams who can improve and iterate on the way they build together is vast, and the best are getting better. If you're in a high-performing team, you're learning good defaults, good instincts, good best practices, standard ways of doing things. Kent Beck, famous programmer, has often said that he's a good engineer with great habits. I feel like, yes, you need to know a baseline of algorithms and data structures, but what makes you a great engineer often has a lot less to do with what's up here and more to do with the socio-technical structures around us. Like, these best practices are not taught in schools. They're like an orally transmitted tradition in our profession. So how do we build these great teams? Well, obviously, we just hire the smartest and best people we can find. I'm sure you know where I'm going with this. No, like, setting aside the question of whether or not you can even do that, if you can evaluate the best engineers, it doesn't honestly really matter. The team is what delivers and owns software. The smallest unit of software delivery and ownership is the team. It's not the individual. And while we tend to think of this from the direction of, well, great people make great teams, it's actually, it tends to flow more in the other direction, which is that great teams are what make great engineers. All of the, everybody's always competing to hire ex-Google engineers, ex-Facebook engineers. But are they, were they hired at Google because they were great at distributed systems? No, they became great at distributed systems because they got to work at Google on some of the biggest, distributed systems in the world for a long time. So if you want to be a high performing engineer, rule one is find a high performing team to join, because which of these two kids is going to be a better engineer in 2 years? The person on the left who gets to deploy many times a day, or the person on the right who gets to deploy many times a year? Every deploy is first and foremost a chance to learn something. And what happens when you've got an engineer from the quote unquote elite bubble who joins a team, in the mid performing bubble? We tend to think that, ooh, we hire this, great person. It's going to raise us to their level, but it works in the other direction. Again, your productivity tends to rise or fall to match that of the team that you join, because so much of your ability to execute depends not on your own ability alone, but on the socio-technical system, the structures that you participate in. They actually have a term for this in the social sciences. They call it the FAE, the fundamental attribution error, which is that we tend to overestimate the impact we have on the system and underestimate the impact that the system has on us. How quickly you can move, how safely you can build. Most of this depends on the tooling and infrastructure that's built and maintained by others. I really strongly believe that technical leadership at its heart consists of and must focus on constructing and tightening and tuning these feedback loops that are at the heart of every system. Feedback loops are things that, it's not just a result that happens once, it's an output that becomes an input. It feeds back into itself, which means that the farther upstream that you fix something, like, the ripple effects throughout the system can be massive. Feedback loops like code reviews, or, of course, the granddaddy of them all is CI/CD. Everybody does CI/CD these days, right? Well, maybe. I think there's this quote that I borrowed from our friends at Intercom, which is that shipping is the heartbeat of your company. And I love that. I love that metaphor, because shipping new code should be as ordinary, as common, as nothing burger, as regular, as predictable, as common, as usual, as unremarkable as a heartbeat. It should happen by default. It should be weird when it's not happening, right? Instead of shipping code being a thing that we have to, it should be a non-thing. And CI/CD is absolutely how we get there, right? So when we ask people, like, do you do CI/CD? They tend to say, Yes, of course we do CI/CD. But then you start to dig into it, and it's like, well, we have a Circle CI account. We definitely send some stuff there. And in fact, most people are doing some form of CI, continuous integration. But the entire point of doing CI is to prepare the path for you to do continuous delivery, or rather, continuous deployment. Continuous delivery is great. Continuous delivery means that at any given time, you firmly believe that trunk is ready to in a deployable state and has no problems. Um, but continuous deployment is what will change your life. Continuous deployment means that once you merge your code domain, it should automatically be deployed by default. No manual gates, no manual steps whatsoever, in as little time as possible, but certainly 1 hour or less. If you're not going to hook CI up to production, if you're going to make all your deploys manually, like, why even bother? Um, you know what? And this is the point at which I realize that I'm giving the wrong talk. I'm so sorry. Um, I'm going to. Oh, fuck. All right, I'm just going to keep going. This is the wrong talk, but it's related to the other one. I'll do some stuff from the other one at the end. Any CI/CD job that ends without having deployed your code to production with a failed run. This is the beating heart of your company. This is the core feedback loop of software delivery. And just for good measure, fear of deploys is definitely the single largest source of technical debt in most organizations. You had one job of engineering leadership is tuning these feedback loops of our socio-technical systems, because the speed, coverage, and cadence of your CI/CD pipeline will actually set the high water mark for your team's performance. And what does a good feedback loop look like? Well, engineer merges a change to master with user visible changes hidden behind a feature flag, which triggers CI to run tests and build an artifact with their changes. The artifact is then deployed to production or another artifact environment with real user traffic. Time elapsed 15 minutes, maybe an hour at the most. And as the Mandalorian would say, this is the way. Feature flags are what allows you to decouple deploys from releases. No to manual QA or the human gatekeeper. You must have tests that you can trust. But 1 hour or less is so important because it's that precious interval of time between when you wrote the code and when the code has been deployed, which is everything. Keeping it short is the difference between lots of toil versus fulfillment. It's the difference between engineering being a creative, generative industry and occupation versus it being just a lot of drudgery. Because right then, when you have finished solving the problem, your head has everything. It knows what you were trying to do, why you were trying to build it, the ways that you tried to build it, what failed, what succeeded, what the functions are called, what the variables are named. You know all of it. But how long does that last? It lasts for minutes, hours, maybe, until you move on to the next problem. It certainly doesn't survive, you having to swap in and out another project, which is why engineers can typically find the overwhelming majority of all bugs in that short interval, that 1 hour interval, as long as they have good observability tooling, as long as they're instrumenting their code as they go, and then they go and look at it. And you ask yourself, is it doing what I wanted it to do? And does anything else look weird? Having a predictable interval is almost more important than having it be fast. They're both important, but having it be predictable is actually what lets you hook into your body's own intrinsic reward systems, the muscle memory, the dopamine hits, because the cost of finding and fixing bugs goes up exponentially with the time that's elapsed since development. A short interval also lets you hold the line with batch deploys so that you can deploy when engineers change at the time, which is what defines software ownership. Otherwise, it starts to get grim pretty quickly. If it takes you several hours or days to get your code out, you're almost certainly not deploying every diff as soon as it lands, which brings you into what I think of as like the software development death spiral, where you've got a longer and longer interval between when the code is written and when it's deployed. So you have larger diffs, which means longer time for code review, which means you spend a lot more time paging projects in and out of your brain, losing state, trying to remember state, trying to recreate state, which means that you're going to start batching up lots of people's changes and deploying them all at once, which really effectively severs your software ownership. You know, imagine if your code is going out within the next 15 to 90 minutes. You are very likely to go and look at it and see, is it doing what you expected? Does anything else look weird? On the other hand, if you're pretty sure that at some point in the next hour to week, your code is going to be deployed along with 0 to 50 other people's, you're never going to go look at it. You're never going to go close that feedback loop by looking at it and seeing, is it doing what I expected it to? Does anything else look weird? Makes it really hard to identify whose code is at fault. If you have 22 different people who ship changes and something breaks, 22 different people, their afternoon gets interrupted. You spend more and more cycles waiting on each other, which means you need more specialists. Soon you need a release team, SRE teams, build engineering teams. All of these people and teams incur more coordination costs, which means you need more people, managers, TPMs, project managers, all of which cost more time. At the end of the day, you can spend your life chasing all of these symptoms and pathologies, or you can fix it at the fucking source and keep it short. Okay, so I'm now going to, I know what happened. I was editing these slides and I deleted one and I kept the wrong name in. So I'm going to switch. That section was supposed to be at the end of the talk, so I'm just going to open the other one and we'll start from the beginning. And it will be all out of order, but that will be okay. That's the one. Okie doke. And let's start from, all right, start from right there. Cool. Oh, I can't do this one. So let's do that. Socio-technical path, yeah, so I give a lot of talks about this stuff. And then a lot of people will be like, okay, cool. So you can talk about all that stuff, right? But also, can you explain how and why we can do these things in a heavily regulated environment? Yes, I can. And I would love to. When I talk about modern software development practices, I'm talking about these things. Owning your code in production, practicing observability-driven development, testing in production, separating your deploys from releases using feature flags, and continuous delivery in under an hour end to end. And when I say separating deploys from releases using feature flags, the reasons feature flags are so powerful is that if you hide code behind a feature flag, it allows you to constantly be deploying your diffs while also letting your product folks, it means you're not having to make everyone see your new code immediately. You can schedule a product release or a feature release or do a stage deployment or a release to internal users first, or etc. What all of these have in common is that they're all about fast feedback loops, getting your code out into production as quickly as possible with as little friction as possible. This isn't about being trendy. This isn't about being super cool. These practices represent thousands, God knows how many years of research and experimentation into how to build better software with better teams. How well your team performs is everything. And here's where I'm going to skip through a little of this. We already talked about that. We already talked about that. And this brings us to, it isn't just about the economic arguments. What the fuck? Where did my other slides go? Do not tell me that I deleted them. That one. That one. I think I deleted my own slides. I know what I can do. I can open these and we'll just walk through them. I'm gonna have to make that whole fucking slide deck again. God damn it. I know where they are. I have them on speaker deck. Decks. All right, so I'm going to unshare this screen, and then we are going to share that browser window. Okay, this is jank AF. That looks better. Those are the right ones. All right. So we were talking about modern software development practices, fast feedback loops, getting your code. You don't see my slides? Do you see? Okay. 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 Full screen, and I'll make this a full screen. All right. Do you see these now? Fantastic. Putting your code in production. If y'all can see my shirt, I'm wearing a shirt that says test and prod or live a lie. Ugh, a little too true this morning. Modern software development practices are all about fast feedback, getting your code into production after writing it. And I'll skip through these, you know what they mean, right? Engineers owning their code in production, meaning you write it, you're on call for it, you cook up for your own deploys, you your code. After you deploy it, you go and look at it in production. Testing in production, separating deploys from releases, continuous delivery, continuous deployment. Okay, so this brings us to compliance and regulatory standards. Now we're going to start by doing a super quick overview of what we're talking about here. It starts with what's called the CIA. It's like the CAP theorem of security: confidentiality, integrity, availability. You must demonstrate that you have policies, procedures, etc. The explain it like I'm five version of this is like your regulations. These are different from your frameworks, right? Your regulations are GDPR, CCPA, HIPAA, PCI DSS, etc. Your frameworks are like SOC 2, ISO 27001, etc. Now, some of these can be audited. Some of them are just, if you happen to operate under the jurisdiction of this regulation, you are subject to it no matter what. There are no real audits for regulations. There are definitely audits for frameworks. What's cool is sometimes you can sort of dual use. You can use your audit path for the frameworks to also achieve regulation compliance. In this talk, we are not going to fuck around with FedRAMP or state banking regulations. But on top of that, you also have written policies for how you're going to comply with regulations, and you may have signed contractual terms for big customers. Frameworks tend to be very loose on the specifics. None of them expressly forbid your modern development practices. However, this is a key point. They may conflict with your own written policies, the ones that you're using to demonstrate compliance, the ones that your security team has come up with, the ones that your legal team has come up with. But policies are living documents. This is one of the reasons it's so important for security teams and IT teams to live under engineering or under R&D instead of under legal. They absolutely need to report to someone who understands not only the risks involved, but the risks of being like overly locked down. Your contract should be negotiated. Is your security team reviewing these contracts before signing them? Are you? If your legal team is signing these contracts without any input from the technical side of the house, you're probably going to be in trouble at some point. Now, our goal here is not to get around compliance standards. I absolutely endorse, we need these things, right? Like I'm old enough that I remember back in the days when you could just slap up, a send mail process in port 25 and start sending mail. You could just whatever data and store it however. The problem is that most of the ways that we've devised to meet these standards don't actually make us any safer. They often make us less safe while also slowing us down. So it's really important that we honor the spirit of the control. As engineers, we are actually the people who are best positioned to find the solution that is actually secure, not only theatrically secure. A lot of people will argue, well, we can't have continuous delivery because we're regulated, we're not building websites, blah, blah, blah. Jez Humble gave this great talk back in 2017. I swiped this slide from him, and he's like, the actual reasons are either our culture sucks, our architecture sucks, we haven't tried, or we don't care enough. But this is a solved problem. Like, this was a solved problem a decade ago. Etsy has been doing this since 2013. The big folks like Amazon, Google, they're not sitting there like manually pushing papers around. Honeycomb does it. Some of your competitors do it, and you can too. And I pulled together some stories of people, and I've been pulling ever since I did this talk. I've been gathering stories from other folks who have been doing this in a good way, and I'm now up to like 20 slides, which obviously I've deleted from my system, but I will recreate them because it's really exciting to see. Here's how branch insurance does it, regulated. This is an actual, they're subject to banking regulations. What they do is, they continuously deploy. It takes them minutes to get, it takes them under an hour to get their code out, but they have, super elaborate serverless test environments. They limit who's look at production for some extent. Here's how Honeycomb does it. SOC 2 Type 2 certification. We auto deploy using a very small bash script once an hour from a cron job. Sprint model is slightly different, so the way that people interpret these regulations should be somewhat different. The point is, we need to stop blaming regulations and frameworks because it's not their fault. There is no regulation or framework out there that is prescriptive about how you need to meet its standards. It is all about how we choose to interpret those standards. It's reasonable for your interpretation to vary on risk tolerance. Like at Honeycomb, we are subject to SOC 2 Type 2, and so is, for example, branch insurance. But we allow our engineers to debug in production because we don't gather PII, don't deal with other people's PII. They gather their own PII. So the difficulty here is that every single product company architecture is somewhat unique. So we can't just like stamp out solutions. We actually little people tend to share how they manage to convince their auditors, how they manage to explain it to their auditors, how they manage to implement something. And I get the whole like security through obscurity, but I really feel like it's holding the entire industry back, that people are not sharing their experiences. The biggest architectural obstacle to continuous delivery is when you want to ship a single line of code, but you have to deploy the entire world. Can you deploy a service you're working on without having to deploy all the dependencies? Can you test without needing an integrated environment? This was one of the main impetuses originally services, for those of you who remember that. One of the most important things to remember when you're talking about architecture is to bring security into the discussion from day one. Bring them in super early. Like, honestly, security doesn't need to be involved that much in your work, but they need to be involved when you're designing. If you need to unbundle a monolith, do not try to rip and replace. Always redesign iteratively. Make sure services have their own databases, et cetera, et cetera. In general, engineers really shouldn't have to be out there thinking about security all the time. It really is mostly when they're setting up a new thing or gathering a new data source. Like, how does this matter? Where should I put it? On the other hand, engineering performance and productivity should always be in our minds because entropy is constantly eating away at our efficiency. As engineering teams, we're not static. Everything's always getting a little bit worse all the time. Things decay, right? You think about it. You ship a shiny new feature, huzzah! But now you've added some surface area to your code base. You've added new users. They're going to start using it in new and unpredictable ways. You're starting to collect new forms of code of technical debt, right? Everything's always getting a little bit worse all the time. And so if you have a high performing team today, but you don't pay attention to keeping it that way, it will not stay that way. Engineering performance and productivity is something that, we should be conscious of on a weekly basis. Compliance is not. If there's one thing that you should take away from this talk, it is this. If you want engineering excellence, you have to engage with security and legal as partners, not as task takers, not as order takers, not as, your superiors. They are your partners. They know things that you don't know, but you know things that they don't know, and they're both really important. I've seen too many engineering leaders who are like scared, like they're shy of engaging, or they feel like they're at a disadvantage. But you are the keepers of the keys to the kingdom. Like nothing gets built if it's not for your team. This is an existential issue. Having a short cycle time is, it's live or die to a certain extent. It is certainly whether your team is going to be happy and high performing and love their life and, outcompete their competitors. Engineering leaders need to fight for this. You need to understand what's at stake. You need to understand the risks and the rewards and fight for it. And this is where we go into the stuff around how well your team performs, blah, blah, blah. We already talked about that. But a fast cycle time is an enormous competitive advantage. It is worth taking up this fight. The happiness of your engineers and your customers tend to rise or fall in tandem. Saying we can't do this because of regulations is just not true. Engineers, we tend to be overly literal, right? But we're not supposed to transcribe between security, legal, and tech. We're supposed to interpret. This is so often a language issue, and like you got to remember that all of this compliance and regulatory language, it comes from finance. Like they copied the language over. And so when they talk about something like, when they say something like business need, you can only do this if you have a business need. What does that mean, right? Or if they say that you need to be, isolated, or that like, I forget the language, but like when they're saying like, it sounds like they're saying that one person has to write the code and another person has to like deploy the code. It's not, it's like legal terms, right? Like any legal term has to be interpreted. Any like security term has to be interpreted, which means you need to understand the the intent behind it and then interpret it, not like just transcribe it like legally or literally. There is no law or regulatory framework preventing you from doing any of this stuff. None. In fact, moving to a fully automated CI/CD system is way more secure. A piece of advice that I heard, that I don't think it is in these slides, that really made sense to me, is that you need to think of the automation as doing the work, instead of like, having a system where you've got one person like stamping or signing off, or you're separating. The software is doing it for you. You need to architect a system that automatically like automates the steps of securing and signing and checksumming and validating and verifying your software. It doesn't all have to be done by humans, even if that's what it sounds like the language is telling you. Architecture is everything. You need to be able to set up an architecture that will fulfill the requirements and then set it and forget it. Documentation is a huge part of what matters. When it comes to auditing, so much of this is about telling them what you're going to do, doing what you said you were going to do, and then documenting that you did it. Like, auditors love that shit. If you're at a place that, a lot of this is resonating with you, how should you drive change in your org? Well, it starts by, building relationships. You need to understand the constraints that they're working under. They're probably being held responsible for a whole lot of bullshit that you don't even know about. If you can come to understand their pain and develop empathy for them, then you're on a much better footing to help them understand your pain. This time, and you need to have some cover from the top. One of the best ways, if you can get the other people in your organization to read Accelerate, I mean, what have some you're saying this stuff. It's way better if they can read a book and they can see the data that's been gathered that shows that this is better, that this works, that this is make or break for businesses. That many organizations have achieved this. It's great at changing hearts and minds. Look for small things that you can do to benefit everyone, but also don't forget like engineering efficiency effectiveness is its own, it deserves being lobbied for. Also learn this phrase. It's a beautiful phrase. Compensating control. What this means is I may not follow the letter of the law, but I have this other system that proves I'm following the spirit of the law. You might need to walk some auditors through this, but we've had a lot of success with this. Observability is really key here. I think a lot of the narrative shift of the last several years is, moving away from a world where you're like SSHing into systems to do things, which is great. This is great for auditing, right? Your engineers really shouldn't need to have full production access. They should be able to debug their code with nothing but commit access and an observability tool that will give them access to their instrumentation, let them slice and dice, ask any question, understand any running state. Observability is what gives us the confidence to move swiftly. I actually agree. If you can't debug your systems effectively, you probably have no business like deploying in 10 minutes or so, because it is very important. Good SLOs actually check multiple boxes for us. There are a lot of things that auditors care about that the SLOs cover a bunch of them, like executive visibility, monitoring, alerts. Instead of needing like a bunch of different systems for each one of these categories, SLOs cover a lot of them. And it isn't just about the security or the economic arguments. Fundamentally, how well does your team perform? This is, at the end of the day, it's defined by your socio-technical systems, and especially by the speed and effectiveness of your feedback loops. Like we said in the beginning of the old set of slides, high-performing teams spend the majority of their time solving interesting, novel problems and moving the business forward. We all want to be on teams like these. This is a quality of life issue, which means I think this is an ethical issue. We have to build teams that are high in autonomy, mastery, and meaning, and you cannot do this without keeping your intervals low and your feedback loops really tight. So, in conclusion, are you too busy to improve? Yes, no, the end. All right. That was a roller coaster of a few slide decks there. I apologize. I must have deleted all my slides. I have no idea where they went. God, that's fun.
No, I mean, as you said, it was a roller coaster. There was ups, there was downs. I laughed, I cried. I mean, I'm not going to say, like I mean, it's an Academy Award nominee for sure. Already, I'm calling it right now. That had everything. Everything.
Well,
Right.
I really enjoyed giving that. I'm glad it's over. Thanks for having me.
Yeah, and scene. All right. Well, thank you so much. For salvaging that between lost slides, between the wrong slides, between losing internet. I mean, we got through it, and this is the thing, right? Fuck it, do it in prod, and we did. So
We did.
right. Exactly. Exactly. We have a bunch of questions. We have a bunch of questions,
Yes.
in the Slido. And if you're watching the stream now, get your questions in now. One, because Charity is here and you want to ask those questions, and two, because this is how you're going to potentially win the KubeCon ticket. Actually, I'm going to make Charity choose a winner, just because why not? So we have a bunch of questions coming in. The top voted question right now, and I'm gonna. Do you know anything about the Schrems 2 framework? And Charity's gone.
Oh, I'm getting
Sad.
packet loss. Come on.
Oh no.
Oh, we're back. We're back.
We're
We're
back.
back.
Okay. So the top voted question actually is around the Schrems II decision and the new rules around prevention of data transfer between the EU and other countries. Do you know anything about that? Otherwise, we can just move on.
No. No, I
All right.
don't.
Very
Sorry.
good. So we're going to move right past that one, and we're going on to, hey, it's Yuri. All right, Yuri. So Yuri actually wanted to mention, actually just mentioned about the engineering management pendulum blog post, which comes and goes, over the years. Thank you so much for that amazing article. Thank you. And Yuri wanted to ask you, where are you now at your career, and how do you like it?
Wow. Interesting question. Um, I am kind of weird IC at the moment. I only have one direct report, and she is Liz Fong Jones, who does not really require much management. It's pretty great, which gives me a lot of time to. I'm spending a lot of time thinking about strategy, honestly, and not having to run an org gives me a lot of leeway to kind of, you know, pitch in with marketing when they're having, when they're shorthanded, or travel and give talks or pinch hit for people. But increasingly, I'm really looking. I've been reading all of these great. I don't have them here books about war and military strategy, and I think it applies to to the business state of the world today. Um, how happy am I with my? I don't. I sometimes joke that I'm only ever happy in retrospect. Like I'll look back and go, "Aha, that was a great period of my life." But truth be told, I things have been in an upswing for me. Like the first 5, 6 years of the company were so brutal, like so brutal, so hard on my health, my relationships, my life, and Christine and I swapped. I was CEO for the first 3 or 4 years. Christine and I swapped, and ever since then, things have been getting a little bit better year over year. They're still in an upswing, so I don't know how much better they're going to get, but they're still getting better.
That's good. I mean, if upward trajectory continues
Good.
up, I mean, sky's the limit, right?
Yeah. Yeah.
All right, so we'll ask some more questions. This one in from Martin. Um, it's a pretty blunt question, but you're a pretty blunt person, so I'm going to throw it at you. How do you point out the cargo culting of security theater processes, ideally without pissing people off?
Oh boy. That's a great question. You know, the answer to every problem, the answer to every question is, of course, it depends, right? What are the personalities they're dealing with? What's their trauma? What motivates them? Using words like cargo culting is usually not advisable, for example. Um, I think, I tried to speak to this at the end of my talk at FinTech DevCon. Somebody asked a similar question, and this guy from Move, or Jack Henry, VP of engineering over there, stood up and gave a beautiful, brilliant answer to it. And he was like, "You have to start by understanding them and the constraints that they're operating under. You don't know what kind of you aren't only one. So you got to start by not understanding that people are idiots. You got to start by expecting that they're doing the best that they can under the circumstances, and you can't go in there with the attitude that you're going to fix their problems for them or that they're stupid. Like maybe you do have legitimately things that can really help them, but nobody's going to give you the space to help them until they feel like you're on their side. So it starts with empathy.
As so many things do. I think a lot of answers to questions of like, how do I handle this situation? How do I talk to that person? And the first answer is always, well, empathy, and then a whole bunch of other things.
Yeah, unfortunately, I get so common that it's almost meaningless, which is why I hesitate every time I say it. I'm like, it's almost like saying the solution is culture. I hate it when people say that. It's just like saying literally nothing at all.
Yeah, fair enough. Fair enough. So just super quick. I think your microphone's dangling right here, and when you're kind of moving around,
Woo.
you're
Oh.
Yeah, it's like something's knocking
Yeah.
against it.
Is
Maybe
that
I'm not
better?
sure. Yeah,
Hopefully
yeah,
that's
maybe
better.
there we go.
Thanks.
Perfect, excellent,
Cool.
super. All right, so we actually have a series of questions around feature flags, actually. So we're just kind of going to
Ooh.
group them together. We had a question about how can we implement feature flags for infrastructure as code. A lot of people are familiar with feature flags if you're doing
Mm.
software development. But how do we do it for infrastructure as code? That's an interesting question.
Yeah, well, a lot of it depends on what your infrastructure looks like and what your code looks like. Um, our team uses feature flags for infrastructure, and it's been really great because it lets us do things like, really fast flip overs and stuff. But I honestly don't really know too much about the state of things today, which is a little bit embarrassing. Um, I know they've been on a bit of a journey with it, and it looks nothing like it did when I set it up. So I'm going to have to punt a little on that one. The TLDR is it's definitely worth doing, but it's not worth being religious about. Like, I will say this, like, I think it's really valuable to keep in mind that there are two different kinds of software. There's infrastructure, which I think of as being the stuff that you have to do in order to get to the stuff that you want and need to do. And then there's your code, right? Your crown jewels, the stuff that makes you the company that you are. And you want to devote as much time and energy as possible to your problems, just, strategically speaking. You want to minimize. This always used to piss me off being in operations, and they're like, it's a cost center. But it is, right? It is. It fundamentally is. It's a very important cost center, but it exists to be minimized. You want to be devoting your developer cycles to your crown jewels. Um, but these two, they move. This is why I'm not a fan of combining them, except in certain overlay. Because think about it this way: your crown jewels, you need to understand them intimately. You need to be able to debug every single request from the perspective of your users. You need to instrument it, and it moves quickly. Hopefully, you're deploying every day, maybe many times a day, right? And you need to be able, that needs to be fast. Infrastructure code changes more at the speed of Debian updates. You don't need to be able to deploy your entire infrastructure fast. And if you put a ton of work into being able to deploy your infrastructure fast, is it usually worth it? Sometimes, maybe 10% of the time, if that's really a real like differentiator for you and your business. But usually it's not. It's really not worth over engineering your infrastructure unless you need to, right? So like, I think it's fine if it's a little bit more jank, if it takes longer to deploy your infrastructure than to deploy your code. um so like, feature flags, I think, are really most useful on the bits that are kind of overlapping. There's always going to be some overlap in the deploys because you need to deploy your code on something, right? So there's bits that overlap there, and having agility and having the ability to like be very scalpel like in what you do with that stuff is very valuable.
That makes perfect sense. Yeah, absolutely. So continuing on with some of the questions here, and again, the questions are all over the place. Um, Maybe because the talk was all over the place, not saying. But the point is, I've got a
Yeah,
bunch of
I know,
questions.
right?
We're gonna throw them at you. This is a question. This is from Michaela, who's one of the DevOps Days organizers. Hi, Mike. Do you think DBAs should be, like the DevOps part of a development team? Should they be their own team? Should it be a separate team? Like, where do DBAs sit if you're putting together teams inside of like
Ooh,
a company?
that is such a great question. I think I would start by asking what you mean by DBA, because I think that's changing a lot, right? Like, the reason that I called the databases book DBR, Deep Database Reliability Engineering, is because, you know, I'm kind of assuming that he doesn't mean like old school DBAs who like all they do is run alter tables and optimize table, indexes and stuff, because I think those don't really exist so much anymore. It's more like you've got a software engineer who knows a lot about data, or maybe a DBA who's learned to code, right? And so, you really do you want your databases to be as little, at least special as possible. To the extent that you can, you want to run them using the same processes and provisioning and everything as the rest of your systems, right? It's never going to be completely achievable because there are differences between data and ephemeral systems and stuff. But to the extent that you can, you want there to be crossover. So I've seen, and if you've got like one DBA or database type, it's different than if you've got like three. And if they're specialists in the different areas, it's different than if you've got like, if they're overlapping, but generally I think I've seen them wrapped into like SRE teams really effectively. I've seen them wrapped into back-endy type engineering teams. I've seen them serve as resources, kind of the way designers do for like durable teams that are organized around projects or products. I think that we ship our org charts, and that's where I feel like there are a lot of these sort of like software engineering adjacent roles, whether it's SRE, databases, designers, where I think that it's almost more important for your company to have a sort of consistent philosophy about how you deploy these resources than any one perfect way of arranging teams.
Yeah, for sure. I mean, consistency is key. Like, pick a thing, and it's not going to be perfect because nothing is, but just keep doing it because it's the thing you're doing.
Keep doing
Right?
it till it stops working and then do something else.
There you go. Exactly. Also,
Yeah.
shipping the org chart. If you're playing the DevOps Days bingo at home, there's another square. We were evoking Conway. So, we got another question here. And here we go. This is an interesting one, especially for someone working for, we're going to use the V word here, vendor. Where to draw the line between build it versus buy it? There are vendors for compute. There are vendors for observability. In fact, there are vendors for everything now.
Everything.
Like everything now. How do you make that decision?
Yeah, that's a great question. The way that I think about it is, kind of back to that. I mean, it has to do with the stage of life that your company is at, for sure. It has to do, but I think the place to start is, what is your core business? Kind of back to that split between infrastructure and your crown jewels. If it's part of your competitive differentiator, you're going to need to know it intimately. If it's not, it's probably someone else's competitive differentiator, and they will probably do it better than you can. This is kind of a good rule of thumb, I think. There are always edge cases, right? The sheer proliferation of vendors that you have is a thing, and the number of vendors who are trying to justify their share price, so they're charging you 10 times as much as they really should. That's a thing, right? But like in general, so here's an example, right? We're big believers of the let experts do what they do. Let's focus on our own ship, and we use Kafka. So like events come into Honeycomb, there's like a thin API thing, they get dropped into Kafka, and then they get read off into our sort of custom proprietary columnar storage engine. And there was a point at which we were investigating letting Confluent run our Kafka stuff because they're way better at it than we are, et cetera. But we chose not to because Kafka basically is part of our database. It's part of the storage system. And at some point, even if we didn't need to know it intimately then, we were very aware that at some point there would come a point when we would need to have that knowledge in-house, how to tune it, where like if Honeycomb is down, we can't just be sitting there waiting on Confluent to bring it back up, right? They're just like, it's too important to us, it's too central, and we know that we need that expertise in-house. So we chose not to offload it because it's too core to our differentiators. So that's generally where I would start.
Yeah, that
There's
absolutely makes sense. Oh, go ahead.
there are also some in-betweeny things. Observability is I think one of the most common ones where, yeah, you should definitely not be like writing your own dashboarding engine and like, there are vendors out there who can do observability way better than you can. But if you're a sizable team, if you're a sizable company, if you're a mature company, there's probably stuff that you want and need that they're not doing for you, which is why having the engineering team between, you're an engineering org and the vendor is really good, because they can make really informed vendor choices. They can make choices about how to invest in the future. Like, they'll have their eyes out watching for things like, open telemetry and being like, okay, we need to do this. They can build libraries. They can do standardization. They can make things drop in and easy to use for your other engineering teams. So there's like this golden path that's blessed, that's super simple. So that's kind of a hybrid model that I think is increasingly going to be interesting.
Yeah, no, that is definitely a path forward that more companies are exploring, right? Where, yeah, absolutely. We have time for one more question, and so I'm actually going to smush two together. Both Martin and Evgenia had very similar questions, and it's around as an IC. You're an IC in an organization, and you want to affect change. You want to shorten a feedback loop. You want to improve a thing. You want to change a thing. What can an IC do to get started on that path? Be it a regulated environment or not.
That is such a great question, and I love hearing it asked because I engineering is such a creative role, and we have so much power as engineers, whether we choose to use it or not. Nothing gets built if we don't build it. If that's not power, I don't know what is. And a place that I've seen people start that is really impactful and really effective and not scary and doesn't piss people off is the often the CI/CD pipeline, the tests run. If you instrument your tests in CI/CD as a trace, then you can see where all that time is going, and you can start to like realize it, or be like, do we really need this one? It's super long. No, we don't need it, or let's replace it with it. Compact, like that run, as you all know, like that amount of time just tends to grow like indefinitely if you don't constantly like pay it back down. And you don't want to have it take like 2 or 3 hours to run tests before you can get a single line of code out. So if you instrument it as a trace, you can visibly see where the time is going. Then it's so much easier for everyone to just kind of drop in and see the impact of what they're doing, make a little tweak or so, and keep pushing that back down. That's a really effective place. And then, when the build times get shorter and the deploy times get shorter, everyone can feel the impact of that, and they're really happy about it and grateful for it. And that tends to buy you credibility to propose other changes.
So I guess the answer there is focus on the thing that you do and then do it really well.
Yeah,
I mean,
do something, make an impact,
yeah.
right? Do it. Like, you have the power in your hands to do things, do them.